Okay, question 11, we are playing with circles. So the circle with equation x minus 7 squared and y plus 2 squared equals 5 has centre C. Part 1 of part A wants us to write down the radius of C. So a little reminder on circles. A circle, centre A, B, radius R, has equation x minus a squared and y minus b squared is equal to the radius squared. So here r squared is 5, so r is root 5. Part 2 of A wants us to write down the coordinates of C. So we've got x minus 7 squared and y plus 2 squared. So it's going to be 7 minus 2. Then for part B, we are told the point P, 5 minus 1, lies on the circle. We want to find the equation of the tangent to the circle at point P in the form y equals mx plus c. So, to find the equation of the tangent, we need to find the gradient of the radius, which then allows us to find the gradient of the tangent, and then when we have the gradient of the tangent, we can find c. So, first up, the gradient of the radius, which I'm going to call m, r. Gradient is difference in y over difference in x. The radius is the line joining the centre to the point P. So, our centre coordinates were 7 minus 2. So, let's do minus 1 minus 2 over 5 minus 7. So 1 minus 2 is, minus 1 minus 2 is 1. 5 minus 7 is minus 2. So the gradient of the radius is minus 1/2. And therefore, now remember the gradient of a radius and gradient of a tangent are perpendicular, so they multiply together to minus 1. So we know then that minus 1/2 times the gradient of the tangent is equal to minus 1. So the gradient of the tangent is minus 1 divided by minus 1/2. So that's positive 2. So, we know then the equation of the tangent is of the form y equals 2x plus c. Now to find the value of c, we substitute in the coordinates of the point P. So we know when x is 5, y is minus 1. So y equals minus 1 and x equals 5 gives us minus 1 is equal to 10 plus c. So c is equal to minus 11 So the equation of our tangent is y equals 2x minus 11. Go. Okay, then for part C, we are told the point Q33 lies outside of the circle and the point T lies on the circle, such that the line QT is a tangent to the circle. We want to find the length of QT. So, a sketch for this is definitely handy, and that is what I've done here. So we know our centre coordinates are 7 minus 2. We know Q lies outside of the circle and has point 33. So we know then it lies to the left and above the centre. Now there are two possible points on the circle where T could be. So I've chosen here to have T on top of the circle. You could just as accurately have it somewhere down on the left hand side of the circle. We could also have a tangent from Q down to this region of the circle. So, we want to find then the length of QT. So let's fill in what we do know. We know that the length from the centre to T, that was never going to go very well. The length from the centre to T, we know, there we go. So we know that length is the radius of the circle. So we know that is root 5. Now, we also could work out the distance from Q to the centre. So, we could work out that distance there. How? Well, we know the height. We can work it out, and we know that length there. So the height is the difference between 3 and minus 2. So the height is 5, and the length is the difference between 3 and 7, which is 4. So, if we call the centre C, then we know QC squared by Pythagoras is 4 squared add 5 squared. So QC squared is 16 add 25. Jolly good day is 41. Getting ahead of myself. It's 41. So QC is root 41. So now again, we are in another right angle triangle in which QT is our final missing length. So now we're using Pythagoras, we can say QT squared, well, it's going to be root 41 squared minus root 5 squared. Now that is 41 minus 5. So QT squared is equal to 36. So, nicely, QT is equal to 6. Cool.